Hey everyone, let's do this problem. It says arrange the bonds in a decreasing order of polarity. And the bonds are nitrogen to iodine, nitrogen to nitrogen, and nitrogen to fluorine. So what makes a bond polar? Well, we want to look at the electronegativity of the atoms involved in the bond, because the difference of electronegativity between the two atoms, the greater that difference is, the greater the polarity of the bond. So it's more about the two atoms together versus just the electronegativity of the individual atoms. So we do want to look at their individual electronegativities though, because that's how we'll determine the difference of electronegativity, right? So let's look at their location on the periodic table. We know our trends on the periodic table for electronegativity. It generally increases going up a group and generally increases going across a period from left to right. So in our first period, the leftmost atom in this bunch here is nitrogen. Then one element away we have fluorine. And then in the same group as fluorine, just a few periods down, we have iodine. So fluorine is definitely going to be the most electronegative. Then this is a toss-up because nitrogen is in a higher period, but iodine is in a group that's further to the right. And nitrogen is actually going to be the next most electronegative, and then iodine is going to be the least electronegative out of these three. But when we're looking at our bonds, like we said, it's about the difference in electronegativity, not just the electronegativity of the individual atom. So nitrogen-fluorine is going to be the greatest difference, right? Because fluorine is the most electronegative. But even though nitrogen is the next most electronegative atom, it's bonded to nitrogen. So the nitrogen-nitrogen bond is going to have zero difference in electronegativity. So that means nitrogen iodine will be the next most polar, and nitrogen-nitrogen will be the least polar. So you know that if an atom is bonded to itself, or to the same atom of the same element, then that's going to be nonpolar, no difference in electronegativity, right? So that leaves B to be the correct answer for this problem. That's it for this one. I hope this video was helpful, and thanks for watching.